Hello friends, today we will see how to code linear regression using NumPy and Pandas. So first of all, we will do necessary imports. For example, NumPy. Then we will import Pandas for making a linear regression database. We are using from make regression function from sklearn. Okay, so let's create a let's create a database for a data set for regression. So just type make regression, specify number of samples you want. For example, here's 1000 sample. How many features you want? For example, for simplicity, we are taking 2, and obviously target variable is 1. And for simplicity, we are setting a noise parameter to 0. We don't want any noise. So this function will return a tuple which contain two value x comma y. X is your feature vector, and y is your target array. Okay, so for traditional machine learning algorithm, we will split this data to train test split. So for this, we will write one function def train test split. It will expect three parameter. First is your feature vector. Second is your target variable. Third is your test size. Test size is nothing but a percentage. It from 0 to 1. First, we will calculate a row length of our data set. For this, uh, we know we have shape function from NumPy. Shape x.shape returns one tuple which contain row length as well as call length. Row length is nothing but your length of your data set. Now we have test size. Now let's calculate a train size. Basically, train size is nothing but how many records you will contain for training purpose, and test size is how many records we will evaluate our model performance on testing on that test data set. Okay, so if you have test size is 0.2, obviously then we will have train size 0.8. It is nothing but 1 minus test size. So 1 minus test size is nothing but our training size. Now let's create a x underscore string. X underscore string. So basically, it is your feature vector for training. So we will slice our x. X is our original data set to train size 0 to train size. For safety, train size is a float. Okay, we have to multiply with our length of a data set, and this expression train size into length will give you float value, and for safety we will convert it, or we will cast it to integer. Now we want all columns. This is our x train. Y train is simple. We know that y is a basically one dimension array, so it is just like 0 to train size into length. Now x test, we have to build this x test from our original data set. X train contain rows from 0 to train size into length, and x test will contain the remaining rows. Remaining rows is nothing but train size into length onwards, and we want all columns. Now y test. So it is same philosophy. It is a one dimension array, therefore no need to specify column index. So let's return this value x train y train x test, y test. Okay, let's call this function trend test split. It will expect it is expecting three parameter x, y, and let's say our test size is 0.2, and it will give you four. It will return four value. First is a x train, second is a y train, third is a x test, and fourth is a y test. Let's see this function is working fine or not. Print, we will print the shape x train dot shape of shape of 0. We only need to check row length, nothing more than that. Y train dot shape of 0, same for x test, shape of 0, y test, shape of 0. Now let's run this program. So I have terminal open here. So Python linear regression.py. Okay, so 800. I think there is a something mistake here. Let's go to the x train. Okay, x train is not 0 to, it is train size into length onwards, and x test is good as well as y test is good. Let's rerun it. 800, 200, 200. Yes, it is correct. Now we successfully built the trend test split. Now it's time to deep dive into linear regression code. For this linear regression, we are using gradient descent. We use weight update rule. So for that, we need a learning rate. Learning rate is denoted by eta. I am specifying eta 0.01. Then epoch. Epoch 100. Epoch is nothing but how many times you will iterate your data set. Now let's initialize the weight. So we know that uh, we have two features. So we will initialize weight with 0. So 0 will the 0 function expect a shape. So if I type x dot shape of 1 comma 1, x dot shape will return a tuple which contain row length as well as number of columns. So x dot shape of 1 will give you number of columns. Now let's initialize the bias with 0. Now let's write a gradient descent. For this, we need to first iterate on epoch. After that, iterate on each training instance. So here I am enumerate. Enumerate will return index as well as the current value. So next train. Okay. Now this just reshape the input feature. Basically, that input feature is one dimension. We have to reshape is for 2 dimension. This minus ip equal to ip dot reshape minus 1 comma 1. This minus 1 specified numpy will calculate this dimension, and the second dimension will be 1. According to the second dimension, numpy will calculate the first dimension. Now let's extract a target variable. Our target variable is nothing but y train of idx. For this is the reason we use enumerate function. Now we have we reshape the input. We also have target. Now let's write equation pred equal to w transpose at the rate input plus bias w. This is a shortcut of doing dot product. It is a basically alternative of np dot dot method. So if we see the shape of prediction spread, let's see the shape. Basically, we are expecting a single value, and we also need a single value, but it is giving a 1 comma 1 array. We need to extract that value. So here just we are writing spread equal to spread of 0. Before that, we just reshape this spread to one dimension. So again, spread dot reshape -1. Just numpy will calculate that dimension. This is a shortcut for transforming a array to one dimension array. Now we have spread. Also we have target. Let's calculate a gradient. Gradient is nothing but your prediction minus target. Now let's write an update rule. Basically, our cost function is a sum of square of error. This is basically this is our cost function. Predicted value minus actual value square. Basically, it calculates the distance between the predicted value and the actual value. So if we take a derivative, then this is our grid. Then pred minus target will come, and this is our gradient. Now let's write update rule. W equal to W minus eta. Eta is our learning rate into gradient into our input. This is the update rule for weight. Now let's update a bias. Bias equal to bias minus eta into gradient. At the end of the epoch, hopefully we will get optimal weight. For checking this, we already have test data set. So let's create a one variable for storing a prediction, ypred. Now let's enumerate on test x test. We already have weight, so we only need to get a dot product. W dot transpose at the rate input plus bias. Now just append this prediction to ypred array. So from line number 41 to 44, we just iterate x test. We already have optimal y as well as optimal bias. We calculate optimal weight and optimal bias using the stochastic gradient descent. It is nothing but a stochastic gradient descent. In the subsequent video, we will also talk about the batch gradient descent. So we have ypred. Now it's time to calculate a score. For calculating a score, we are using one sklearn method. From sklearn.metrics import R2 square. R2 score is nothing but a coefficient of determination. So basically it is a accuracy score for regression. So accuracy score is R2 score. Now R2 score expect a parameter y true. Y true is nothing but our y test, and second one is our prediction. Y underscore spread is our prediction. Now let's print the accuracy. Okay, now let's save it. Let's run it. Before running, I'm clearing the window. Okay, so one error here should be, what is the error? Target equal to y train idx. Index 200 is out of bound for axis 0 with 200. Let's fix it. I think there is a problem with our train test bed. Train size 1 minus test size x train is a 0 2 and oh, y train should be 0 2. Okay, now let's run it. Oh, we got accuracy 1. Accuracy 1 is nothing but 100%. Now let's let's see whether it is 100% or not. For this, we will create a data frame which contain a prediction as well as our target. So tf equal to pd dot data frame. So we will use a dictionary to create a data frame. So our column name is spread. Spread contain y spread. Second target variable. Basically, our it will get y underscore test. And if when you are using a dictionary to create a data frame, you need to specify index. So index is nothing but row length. So y test dot shape of 0. Now let's print top 10 rows. tf dot head 10. Let's see whether we are getting 100% accuracy or not. Yes, we are getting 100% accuracy. Target is a minus 98. Our prediction is also minus 98. It is in array, so just write 0 here. Now it will, yeah, this is it. Prediction is a minus 2.04, target is minus 2.04. So all the values are correct exactly. So this is how you will code a linear regression from scratch without using sklearn. Thank you so much.